Welcome everybody to the 9th webinar of the WCRP Digital Earth's Lighthouse Activity webinar series. My name is Rosimar Rios Berrios from the U.S. National Science Foundation National Center for Atmospheric Research in Boulder, Colorado, and I'll be one of your moderators in today's event. This webinar series is part of the WCRP Digital Earth's Lighthouse activity, and the aim of this series is to help maintain more regular and open dialogue between active researchers and users on the development and evaluation of kilometer-scale global and large domain models across the world. We plan to hold seminars every 2 months, spanning a range of groups working on kilometer-scale modeling around the world. We're very fortunate today that we have a speaker from South America as an example of how we're covering our entire planet here. You can find a recording of the previous events via the webinar webpage, which is going to be linked on the slide you're seeing. And the focus today is on South American activities with a regional kilometer scale model. Before we get started, I will pass it on to our other moderator today, Hugh Lewis.
Hi all, and a very warm welcome from my side. So I'm Hugh Lewis from the Met Office in the UK. And just before we move on to introduce today's speaker, I want to provide you with an overview of today's events and how we're planning to support interaction. So once our speaker will start presenting their talk, and we will try and round off within the hour with enough time for a question and answer session. So during the talk, please feel free to use the Q&A feature that you should be able to find at the bottom of the Zoom window to type in any questions you may have as we go along. We should also find that there's an upvote, so a thumbs up, where you can try and prioritize the order in which we will get to questions at the end. We'd ask if you can please reserve the chat function for any more technical issues related to the webinar as we go. So a reminder to please use the Q&A for questions for our speaker. Just encouragement really to offer any questions as we go along, and please don't be shy in coming forward, and hopefully that will provide us with a rich discussion at the end of today's presentation. As we've warned you, we'll try and wrap up for time. If we find we're running out of time, but I'm sure we'll have plenty in the event. So back to you, Rosie.
Yes, as I said earlier, today's webinar will focus on kilometer scale modeling over South America, and our speaker will be Dr. Lluís Fita, who is a researcher at the Centro de Investigaciones del Mar y la Atmósfera in Buenos Aires, Argentina. Lluís received his PhD from the University of Balearic Islands in Majorca, Spain, where he started his career doing numerical modeling of Mediterranean cyclones, also known as medicanes. Lluís has co-authored over 40 scientific papers, and the majority of them have focused on regional modeling using kilometer scale models. His research areas include Mediterranean meteorology, mesoscale meteorology, regional climate modeling, model development, and model coupling. He's involved in many international initiatives, including the recent field campaign that happened, Relámpago Cacti, as well as in a GWEX project called Andex, a regional hydroclimate initiative for the Andes. Today, Lluís will share with us his work on South American activities with REG IPSL, Regional Earth System Model. With that, we welcome Lluís to lead the presentation, and the floor is yours.
Thank you very much. Okay, you see my slides?
We can see your slides and we can hear you loud and clear.
Okay, thank you very much. Thank you. Good morning, everyone. Thank you very much for giving me this opportunity. It will be very meaningful for me and for the community. And this is a talk that I prepared, but without the REG IPSL team, that will not be possible. So thank you also to them. And thank you, Rosemary, for giving me this opportunity to give this talk in this webinar series. So I want to talk about the REG IPSL and the activities that we are doing here in South America with the regional Earth System model. So, what are the Earth System models? They are really common, they are used to be common global models, but why not doing that also regionally? So what is an Earth system model? I think that most of you are familiar with that term, but an Earth system model, it's that model that has a representation of all the 6 main components of the climate system. I define them as 6, being the humanity, the atmosphere, cryosphere, ocean, land, and the biogeochemistry. Yeah? They are usually made above state-of-the-art single models for each of the components. And with them, we have a full, complete transfer of the energy and the mass between the components. They provide us a holistic representation of the climate system, including all the interaction, responses, and balances between them. They have the Earth system models give us a high degree of complexity of the system, and they used to be very highly computational demanding. So why not going regional? If we go regionally with an Earth system model, we can easily, much more easier, increase the complexity of the schemes of the representation of each of the components. We can have non-hydrostatic dynamics, PBR schemes with higher order, double moment of microphysics with a lot of species. We can reach easily much more high resolutions, increase also the use of the modeling tools, because usually there are much more worldwide regional climate modeling institutions than global climate modeling institutions. We are much closer to provide climate services, and we have also much more closer interaction with impact and stakeholders. If we go regional, it can be an easy benchmark for the future climate scale global climate model developments. Why also we're going regional? It's an easy way to understand the new needs in terms, for example, of ancillary data, which are the necessary data that we need to be able to perform climate simulations at high resolution. We can understand in advance future challenges like stability, new biases, and for example, going regionally and high resolution, we can have the emergence of new strong responses to coupling that we cannot see before in advance. For example, here I provide an example of how the inclusion of the water table and the response of the climate system depends on the resolution. This is an article for Barlash in 2021, when on the left side you see 27 kilometers of the surface temperature, and below we have in the last row you see the difference between observations and the model. As resolution increases to the right, you see how the bias gets reduced, and the impact of including the water table as a result of including the water table. Because the second row, you see what's happening when you include the water table. So we have emergence of responses to the coupling depending on the resolution. That could be that seen in advance when they are using regional climate model. So what is the REG-IPSR? The REG-IPSR is the Regional Earth System Model of the Institut Pierre Simon Laplace. This is a multidisciplinary team from different reference institutions led by Jean-Paul Cher and other institutions from the world. Let's say here in CIMA from Argentina, IGP in Peru, and some other ones from France, not only from Paris. Why are needed the regional Earth system models? They provide us with a full high-resolution representation of the climate components and their interactions. They allow us to have convection permitting through climate runs and enlarge the community of users and development of the tools. They are useful because they provide us with a comprehensive study analysis as never before in detail of the dynamics of the different components. They provide us data for climate services, or more suited for climate services, and providing also with an interaction with our communities, let's say the people from energy, food production, infrastructures, or health. And foster, in the case of the IPSL, the collaboration between all these researchers, which are about 1,000 researchers or more. Also, regional Earth system models are vital for the IPSL in terms of that allow us the transfer of global model knowledge to the limited area realm and vice versa. It provides also a tool to provide high-resolution limited area coupled simulations with the different IPSL models and can be easily, quickly useful for the IPSL community and worldwide. So we can see that the regional system models are neat, useful, and vital as a tool for the IPSL for facing the challenges for the regional climate science. Which are the components of the REC IPSL? In the REC IPSL, we coupled the existing IPSL models in a limited area domain. This covers the atmosphere, land, ocean, chemistry, and with using as coupled OASIS MCT and the input-output, the XIOS libraries. So land and ocean components are already the IPSL's GCM components, whereas the atmosphere, the Earth model, is not from the IPSL. And the chemistry is already coupled to Earth, but not already in our system. If I go component by component, sorry, before I say that we are interchanging 40 different variables between the different models, that is done with OASIS that at the same time makes the interpolation to different grids used in the coupling. Wolf and Orchidea use the same grid, whereas Nemo uses a different grid. And the interpolation of that is doing via OASIS. And each component is integrated at different time steps. Wolf and Orchidea use the same time step of integration, which is about 4 times the resolution of the atmosphere grid. But also Orchidea can run with an asynchronous coupling that provides us a faster integration. And Nemo is integrated at every 12 minutes. The first triple coupled run was done in the Met-Cortex domain, which is a domain that covers all the entire Mediterranean domain and all the rivers that goes to the Mediterranean Sea, except the Nile, on July 2019. Now, component by component, the ocean, using as reference the Met-Cortex configuration, we're using Nemo, the 3.6 stable version, at a 12-degree resolution, horizontal resolution, with 75 vertical levels, and with different components taken into account that. For example, we have a buffer zone for the Atlantic. We cannot couple to the Atlantic Sea, that will make our simulations too much costly. The Black Sea is not included, because the Dardanelles Strait is too narrow to be able to be properly simulated by the Nemo at 12 degrees of resolution. But, for example, the estuaries are directly integrated in the Nemo grid, and the coastal runoff are directly discharged from the routing scheme from Orchidea. For the spin-up of the ocean, we perform an offline initialization of Nemo of about 50 years or more. For the land component, we use Orchidea, the full version 2.2 version of the model, which encompasses 11 soil layers, 15 PFTs, all different dynamic vegetations as dynamic LIE, all the different batches of CO2 and nitrogen, and of course the physics-based river routing scheme. In this simulation, we are not using the interactive technology module because it's giving some problems. When I'm talking about the regional routing version of the routing scheme from Orchidea, I'm talking that we have the river represented directly in the model. So when Orchidea is running, it also provides us with the outflows of the rivers, which, for example, in the Met-Cortex configuration, that it's using 36 HTUs per grid box, atmospheric grid box. We are simulating 200 rivers outflowing to the Mediterranean Sea, and the routing map is incorporated using the Merit or HydroSheets database. And recently, we can also activate the floodplains scheme. For the Orchidea model, what we do is perform a 10 years offline initialization in order to have all the rivers already the correct initial situation, and also the temperature and land humidity. For the atmosphere, we are using WRF. We coupled the recent 4.3.3 version of the model. And in the MetCordex domain, we are using a 20-kilometer resolution using Lambert conformal projection at 46 vertical levels at the same degrees as Orchid. We can use all the world physics except the land because we're interested in Orchid, so we are not using the world land component, instead we are using Orchid land model. We have to develop different tools, like one tool to be able to force directly with NetCDF data for WRF, and also we need to modify the definition of the domain to remove all the inner water from the land bodies because it's needed for the Orchid routing scheme. As I said, the coupler is done via Oasis MCT, where we interchange 40 different variables with the different components. Between WRF Orchid is done every 60 seconds, whereas within EMO is done every hour. And interpolation to each different grid is done directly by Oasis. As the input-output data, we are using the XOS, which has been incorporated in all the three components, also in WRF. And also we incorporated there the Cordex required variables as output. The XOS is a very powerful input-output library which uses XML and C++ coding, which provides a sort of different servers and resources, parallel resources that allows us to have a very nice scaling of the model without the bottleneck of the input-output as in other models. At the same time, because we're using IPSL tools, we can also use the different tools that IPSL is using to manage and follow the different, for example, experiments. So we use as workflow the lead ECCM. We can monitor the simulation using Ernest, and we can also plot in some real-time plotting using CIMA. We are holding weekly meetings to know the development of the model and which are the new outcomes of the model. And we hold all the code in a Git repository, which are available. The model is already, the system is already can be running in the different HPCs in France, called Ibris or TCC, and the different other HPCs. We can run the configuration of the RegITSL, all the three different components offline, or we can start different combinations, WRF with MIMO or WRF with Orchid, or the three components together. In South America, what we are doing in South America? I'm the coordinator of the RegITSL experiments in South America, and we call that project AMSUT, and I'm also an active member of the development team of the RegITSL. In South America, it's a collaborative effort between for the development and the use of RegITSL between LMD, IPSL, CIMA in Argentina, and the ERD in Granada, Peru. Already in AMSUT activities has been two different PhD theses, Anthony Schaffer and Joanna Gudela, who I think he is here. And we got granted CPU time in the GenC French resources since 2017, about 25 million CPU hours. We also succeed in different funding applications from different institutions from Argentina and international. And through the use and different activities in RegITSL, we built up a network with different partners from different South American countries, from Colombia, Ecuador, Brazil, Chile, Bolivia, and France. Also, we are, from AMSUT perspective, we are also participating in different international activities like Cordex, the GDR CH2 and the funded networking, the UN Index program, Climate Suits portal, the climate risk WCRP like health activities, the Cordex flagship pilot study about urban environments, and I'm trying to host a node for the Digital Earth Global Hackathon that will happen in May about global climate model. And also I participate also in the SAC in the NCAR South American Affinity Group team that I forgot to put in the slides. Sorry. So, which are the activities, scientific activities? We have defined all these 4 different domains. Mainly, we have the big domain, which is a subdomain at 20 kilometers, which covers the entire South America. And in this domain, we performed already 2 experiments. One was focused on the sensitivity of the land-atmosphere interaction on sulfur water bodies. And a second one about the impact of deforestation in the regional climate. And we're trying to provide a coordinates data set using RegiPercel for South America, 20 kilometers using CIMA6 data. We also have a high resolution domain at 3 kilometers, which covers the Altiplano, but with different technical problems, we cannot now the simulation and this experiment is already on hold. We also planned to have atmosphere, land, ocean, Atlantic experiments focused on cyclone activity. That will be the first 3 coupled runs in South America. Other AMSUD activities are, for example, our contribution to the model development, which covers the high resolution Orchidea routing and floodplains schemes, the inclusion of the cortex diagnostics in the RegiPercel, the adaptation of the WRF tool to define the domains specific for RegiPercel, and the direct forcing with NetCDF files from WRF. At the same time, we have also involving in capacity building. For example, I gave a different workshop about geophysical fluid dynamics and Fortran coding. In 2019, we got a visit from Jean-Paul Scher and we gave a land atmosphere interaction and the simulation PhD course. And I have been hosting 2 editions of the geofluids modeling PhD course. And in this July, I hope I will have again another edition. At the same time, we already know that there is always the issue of how to access the data and how to manage the data. So in that sense, we activate a proof of concept resource called Papademos, that the idea of this resource is to facilitate the managing and the storing of climate data and perform in situ diagnostics of the data without the need of having a local computer. Trying to mimic, for example, huge systems like the Jasmine or Levante, as you know already in Europe. But this would be a South American version of that. And of course, much more small. So going much more in details in our scientific activities regarding on the floodplains and land atmosphere interactions. So we have, the PhD thesis of Anthony Schaffer, which was co-directed by Jean-Paul Scher, Anna Sorenson, and myself, about a high-resolution numerical analysis of the land river floodplains atmosphere interaction in the Plata Basin. As you might know, South America is a continent of floodplains. Here you can see there is a large rivers, huge precipitation, and also at the same time it's a very flat area. So from that we got a large amount of huge wetlands and floodplains area. For example, in this number 1 in this slide, you can see the location of the Pantanal, which is the largest wetland of floodplains area in the world. In this regard, the PhD thesis of Anthony Schaffer was based on the creation of a floodplains scheme for high resolution purposes, in which that allows us to flood the rivers in the aversion flow. So usually the rivers they converge. So as you go away from the mountains, the rivers start to converge to become a huge river. But with the floodplains scheme, we can go, the water goes upflow, so that becomes divergent. So when the water is also in the floodplains, this can be evaporated and can be flooding the present ice sheet. When we activate this new floodplains scheme, what we got that the river discharge, it gets modulated by the inclusion of these floodplains schemes, and which becomes much more realistic when compared with observations, as you can see in this Taylor plot, where the squares and the round points are when the floodplains scheme is activated using different atmospheric forces. Also, when we perform land-atmosphere coupled simulations, there is an impact, a local impact in precipitation when the fluid range is activated. Here you can see the difference when in precipitation in summer, when the fluid range scheme is activated and when it's not activated. In blue, you see areas where the precipitation is increased when the fluid range scheme is activated. Not only in the local scheme, we also see that the activation of the fluid range scheme, mostly focused on the Pantanal area, makes that the important low-level jet from the Amazon gets modeled also. So this low-level jet, when we activated the fluid range scheme, this low-level jet gets much more closer towards the Andes mountain range, as here you see in these plots, and it gets much more towards, much more lower in the levels, as you can see in these different vertical sections. Another aspect that we used the RegIPSL was to analyze the impact of in the regional climate of the deforestation. That was in collaboration with a project called Amanecer, led by John Carlos Espinosa from the IRD in Peru, where we performed 30 year additional simulation with RegIPSL imposing the Amazon deforestation. In this regard, there are two different publications. Here you can see what does it mean to include the deforestation of the Amazon. You can see in the control panel, you see the green is the actual, more or less in 2010, vegetation in the Amazon. And on the right side, you see the projected deforestation in 2050 from Suarez and Filho. So we changed the vegetation towards the deforested vegetation. In doing that, we see that there is a decrease, a difference on 40% of precipitation in southern Amazonia, south of 5 degrees, during the onset of wet season, September to November, and there is a large impact on the local water cycle. When we have a deforested grid point, the atmosphere, for example, gets 8 times drier than when there was the forest, the tropical forest. In the same sense, we analyzed identified 9 different weather patterns, and we see, according to our simulations with the deforested Amazon, that we have a regional impact, a regional feedback, which means that there is the dry season on the Amazon starts before and becomes much more larger because the different weather patterns associated to the triggering of the wet season of the Amazon basin, they become much more later and last less time. So we also plan to have the outflow domain in collaboration with the CCC project, in which we will perform a first calendar scale simulation in South America with RegIPSL to produce high resolution climate data for impact studies on water resources and agriculture in the area. Also in collaboration, because the interest is to reproduce the hotspot also in the precipitation here in the central area of the Andes. So, which are our future plans in terms of simulations? So our plans is to perform the cortical simulations for the entire South American domain for 20 kilometers. By now we have the control run, but we are experiencing some technical problems with the CIMA present and future simulations. We're trying to solve them. And in the flood outflow domain, we will perform the control run directly with ERA5, and we will use the CIMA6 outcomes from the cortex-like simulations as forcing for the present and the future climate. Another future plan is that involves a new project that we managed to pass to the final phase. We haven't not yet been granted the project, but this project is called South American SA himself, which is a project about climate services for the entire South America, which is in collaboration with 13 different South American institutions involving numerical weather and hydrological services, institutes, research institutes, and universities, and 3 different French institutions. In this regard, focusing on the digital Earth lighthouse activities, in the modeling working package, we are going to use RegIPSL to test climate services at kilometer scale in 2 different demonstrative domains. The first one for food security in the north, as you can see here on the right, and the second one for water resources at the center of South America, covering the entire Paraná River Basin. In these 2 domains, we are going to provide a test to provide regional seasonal ensemble prediction systems at kilometer scales using the global seasonal ensemble prediction system as input for SIM data, and also to provide to each domain in the second phase climate projections. In this same project, the data working package, we are going to provide, if we want the project, a regional node to storage large amount of data and provide in situ data analysis for all our partners, like Papademos, but in much more large capacities. So, in terms of RegIPSL, we're going to work towards the inclusion of the representation of the urban tile in Orchide, which is related to the Morgan Lalonde de Lepage-Lake PhD. We will need to incorporate the representation of the floodplains, but in forest, because this is the dominant type of floodings in the Amazon River Basin. By now, we have the floodplains, but only in the plains and with grass. We will need to make sure that we have include the representation of the lakes from Orchide, because by now we cannot simulate in the Altiplano domain at high resolution because we're missing the Titicaca Lake. And without the Titicaca Lake, it doesn't make too much sense to perform climate simulations. We also start to see that we need a representation of the water table, or the underground water. We also will try to activate in RegIPSL the irrigation and the dam modules from Orchide. We would like also to incorporate Chimera in the RegIPSL. And in the near, much more far future, the idea is to replace the WRF model for the atmosphere by a limited area version of Dynamico, which is a global, by now it's a global circulation model, only as atmosphere only, but which is based in a new concept of unstructured grids and much more suited for high resolution and much more scalable. And another maybe wish list would be to couple a 3-dimensional license model to the RegIPSL system like Elmer or ICE. As final words, RegIPSL is working, is useful, and has been providing useful results for us. It provides also the inherent complexity of RegIPSL allows us to start new analyses and face new challenges, of course. Although we are a tiny community, we are only 3 or 4 developers and at least more or less 10 users, the enthusiasm keeps us moving on. And in terms of, I have been thinking about a little bit about how Global South can contribute to the model development. Yeah, because I mean, model development doesn't require large resources. So this can be a good niche of contributing to cutting-edge science from the Global South. For example, providing local expertise in specific processes and climates that they need to be also incorporated in the GCMs, RCMs, but because usually the development of the models happens in the north, there is a kind of missing bridge between local expertise and the development of these models. And also, we can have the technical expertise to contribute to develop new models and contribute to enhance the models. So, thank you very much. If you have any questions, I'm happy to answer them.
Thank you, Lluís, and thank you for the excellent talk and the introduction to the Reg IPSL system and all of your work across South America and its applications to other parts of the world as well. It's been great to have a focus on the regional modelling activities and understanding of how it's supporting wider development aspects as well, linked from regional to global scales. Thank you again for a great talk. We've got some time now for some questions and for some answers and some discussion. So please can I encourage all of the attendees today to raise any questions or comments you may wish to flag in the Q&A box. I trust the Q&A is working. Maybe if somebody is brave enough to test it out for us, that would be fantastic. Maybe to help kick off, Lluís, can I ask you to reflect a bit further? In your introduction, you were flagging, you were raising some commentary about how the kilometre scale regional modelling has been used to support global model developments at I think at IPSL, and I wonder if you want to comment a bit further on maybe some practical examples of where you're seeing those benefits.
A good question. As you might know, the regional climate models, they tend to have schemes for PBL or for microphysics. They are much more complex than the ones included in GCMs. Yeah. Computational resources are limited, so we cannot have all the complexity that we have currently in the RCMs in the global climate models. So in this regard, I think that the RCMs can be very useful on looking what works and not what doesn't work in terms of complexity and for high resolution. And this knowledge can be transferred to the GCM community and say, look, in the regional climate model, we see that this is working, this is not working, and this part. No? When I was in my first postdoc in France, in IPSL, I was working in getting the physics from the LMDZ, which is the atmospheric component of the IPSL GCM. And I took that physics, so the microphysics, the PBL, and so on, I include them in the WRF model. So the idea was to see how, at high resolution with a non-hydrostatic dynamics, the physics of the IGCM was dynamically responding at these resolutions. So we got quite nice results, but was hard work to do because was a huge gap between the RCMs and the GCMs. So it's not that simple to do, but I think that we can work together and the GCMs community can take advantage of our knowledge from RCM communities. Yeah, because I've been much more time working at these resolutions and so on.
Yeah, thank you. And I guess a plug back to the last talk we had around the global Digital Earth Hackathon, and you've flagged it as well. And perhaps that's a great opportunity for people to engage in these kind of activities. So we'll put a link in the chat in a second to encourage registration. Rosie, I'll pass to you.
Sure. So I would like to encourage the participants to type your questions. And there we go. We have a question from Julie Deshies, co-lead of EPSL Climate Modeling Center. Well, first of all, Julie, thank you for being the brave one to test our Q&A box. Thank you so much for typing your question. So the question for you, Lluís, is, do you envision to revisit the parameters for the configuration in South America as compared to those of the Mediterranean, for example? If yes, which method do you prefer when calibrating parameters?
So in RegIPSL, we are not calibrating the parameters. So you use as they come from the box, let's say. Yeah, maybe we'll change the physics, for example, from the atmosphere. Maybe we'll not use the microphysical scheme used for the Mediterranean. We'll change that to another one, or maybe we'll change the PBL scheme to another one, because doing sensitivity tests in South America, we can see that different combination of the schemes behave better in South America than in the Mediterranean Sea. Yeah, that's one aspect. Another aspect that maybe we can think about that, for example, would be related to the PFTs, you know, the representation of the vegetation in South America. Most of the PFTs or the characteristics of PFPs are suited much more for Europe or let's say North America because it's where all the data is available. So maybe we would need to think about what does really means a broadleaf tree in Amazon. For sure, is not the same as a broadleaf tree in Europe. So maybe some of the parameters of the PFTs that maybe will require some fine tuning, or some agriculture models in Orchid, they also will need some refinement. But for example, here in South America, we have coffee as a food production, yeah. But there is no, as far as I understand, there is no in the agriculture model in Orchid, there is no representation of such a vegetation as orchid, as coffee, for example. So these aspects, we can get this project going on from climate services in South America, thanks to the North domain. We'll be in contact with coffee makers, and maybe with that we will be able to introduce representation of the production of coffee or the production of soja or potato in the agriculture model in Orchid.
Thank you for that. Yeah, for that answer. And it's like, as you said, like many of these model physics get developed for specific or get thoroughly tested in specific regions of the world for particular reasons. And so it's very interesting to hear your perspective on how we need to rethink about them. For example, the coffee plantations being such a big part of the vegetation in South America. I'll pass it to Hugh for the next question.
And the next question says, thanks a lot for your presentation. I was wondering if the inclusion of tropical vegetation diversity and associated processes that are sensible to climate, for example, tree mortality by drought, is to be considered in Orchid and Reg IPSL developments.
I'm not a direct specialist in Orchid. In the webinar there is Jean Porchel, which knows much more details about the model, and other people from IPSL. But what I can say is that yes, Orchid has into account the life cycle of the vegetation. So see if the plants can die. Let's say if you have not enough water, you see how the vegetation starts to die, and that makes you see in the simulations that your LI and so on is going down. So this would be a sort of dynamic vegetation response. As far as I understand, this life cycle of the vegetation is mainly focused on precipitation, I think. So I don't know if there is any specific life cycle from the Amazon. I don't know. I'm not a specialist on vegetation in the Amazon, so I can know. But if there is any dynamic aspect that maybe it's important for the dynamic vegetation in the Amazon, and we are missing that in Reg IPSL, that I think that should be something that we can think about to fix that.
Thank you. And if there are anybody more closely related to the Orchid developments and want to address that question more directly, feel free to use the Q&A again to keep that conversation going. Just in the meantime, I guess changing tack a little bit into the ocean and atmosphere feedbacks. I'd be interested in your perspective on how sensitive you're finding the regional South American results to having a dynamic ocean. I guess it's an area I'm less familiar with, so interested in your perspective.
We have not yet performed any atmosphere-coupled ocean simulations of America. That's something in the wish list that, as you can see, we're only 10 people, so it's not that much person to work on everything. So we are hoping that we'll be able soon to start to perform some initial tests for where the ocean will be coupled to the atmosphere. Yeah, so that's something that we are really interested in. That.
And what kind of feedbacks are you looking for? Have you got particular missing processes, I guess, in our atmosphere-only approaches that you're looking to capture?
Yes, I guess there are different aspects. I'm not an oceanographer. Yes, with these air system models, you need to be a specialist in everything almost, which is impossible. So I think that, for example, we're very interesting on see if we can reproduce the cold water surgences in the coastal line of Peru. which is very important for the fish production and the climate in the area. For example, also to see, for example, in the Atlantic, how the sensitivity on the Caribbean Sea impacts in the precipitation in the Colombia and in Venezuela, which there is some studies that show that a warmer Caribbean Sea produces less precipitation in Colombia and Ecuador, and all this interaction at large scale interaction. All these topics are relevant for us. So once we are able to simulate the ocean and the atmosphere coupled, that will be also something that we will need to start to look on.
Thank you.
All right, we've got some other questions coming in. So Jan Pochet says, actually it's a comment. So we have seen that when we have introduced the floodplains, the life cycle of the vegetation in this region was better represented. It is in Orchidea 4 where the vegetation mortality is much better represented, but we have not yet done EPSL simulations with Orchidea 4. Thank you, Jan Pochet, for that comment. Do you have any reactions to that, Lluís?
No, I mean, he knows much more better how Orchidea works, so I'm very glad that he contributes to that, to answer better the question. Thank you, Jan.
Okay. And then the next one, thanks for the nice presentation. Regarding WRF and Orchidea, is there a preferred physical dynamics configuration in WRF for coupling with Orchidea? Again, if you can comment on that.
As a WRF user, I would say that will depend so much in what are your interests, which variable are you validating, in which area and which period. So I think it's impossible to see where it works the best. That's the first of all. No matter if it's with Orchidea or NoMP or any other land models from WRF. Our experience is we perform some sensitivity tests for the entire South America. I was doing that. I haven't published that because no time as usual. And there are different dependent. The sensitivity was working better in the north with some combination of physics, but was working worse in the south. It's always this never-ending story that you never know where it's going to be work better depending on the physics. So first you need to see which is your interest, and then go for that. I mean, it's not a simple answer. I mean, it depends so much in different aspects that it's difficult to see a simple answer. Because also in South America, we have so many different climates. So you have the wettest and warmest from the Amazonia, but then we have the driest from the Atacama Desert. So the different amount of climates that we have to tackle in South America makes almost impossible to have all of the climates happy with nice results. So this is difficult. Yeah. It's not as simple as that.
Yeah, I can imagine it's very difficult. Thank you for that perspective. With no more questions coming in, I'm gonna use my moderator privilege to ask you one. So it was very interesting to see the experiments with deforestation, and
Yes.
just recently saw another talk with a different model. They were using the ICON model, and they found that when they do an experiment where they play with the deforestation of the Amazon, they see an increase in the water vapor flux coming from the Atlantic and the Caribbean into South America. Do you see that as well?
I think no.
Okay.
No, I don't know all the details, but I remember, I mean, what I present, no, that there is a change on the frequency and the length of the 9 different weather types that we have.
Okay.
But now I don't have on mind if some of the weather types get the water water transport was increased or not. What I know is the frequency and intensity, the length, they get shorter, the wetter ones.
Interesting. Yeah, so this continues to highlight some of the challenges even with our kilometer scale models.
Yes, exactly.
All right. I don't see any more questions coming in. So with just 10 minutes to go, we're just gonna close early here. Thank you so much to Lluís for bringing up this talk about South America and the REC IPSL modeling initiatives. It was really great to have you, Lluís, and very informative to learn about the challenges as well as the ongoing initiatives going on for modeling in South America. Thank you also to the attendees for joining us today, and thank you so much for your questions, those of you who dared to ask questions today. You?
And so any feedback on today's event is very welcome and can be sent either to Rosie or myself, and hopefully you can see our contact details on this slide here. We'd also be very happy to hear from anybody who wishes to volunteer a future seminar on a related topic, either from yourself or as a group of contributors from a particular organisation. We'll keep the webinar web pages updated with news of future events, and you should keep an eye on your inboxes for invites to register for future events. I think we're looking forward to May, when we may, in fact, hear from NCAR and Met Office around our activities spanning the regional to global modelling activities. And then later in July, we're hoping to showcase some of the work that's going to be developed and delivered through the upcoming hackathons. So please look out for those events. But if you again wish to contribute seminars for later in the year, we'd be very, very happy to hear from you or any recommendations for other topics to cover.
Yeah, and we'll also inform all registered participants when the recording of today's event is available online. So please do feel free to share it with your colleagues and in your organizations and networks when it's available. And please encourage them to register for future events. So thank you to Maureen and the WCRP Secretariat for all their support. And thank you all to those of you for joining today. We look forward in joining with you again next time. All right, this concludes our webinar. Bye-bye.